The next thing that we're gonna study is gonna be about we gonna compute a double integral. However, we gonna reverse the order. The question that we're gonna have is gonna be in example 12 that when you see this kind of double integral, it's gonna turn out to be the function that it is impossible to integrate. The way that we're gonna deal with this problem turn out to be we're gonna have to reverse the order of integration from dy dx to dx dy, and we're gonna be able to integrate from that part. So the first example that I show you only for reversing the order turned out to be example 11. Okay, example 11 asks you to sketch the region. So the first thing that you must do is gonna be you're gonna sketch the region, and you're gonna change the order. So it's gonna be two problem in one. So it's gonna be two steps. The first one is gonna be sketch the region, and the second one will be sketching, the first one is gonna be sketching the region, and the second one will be changing the order. So the thing that we're gonna do in this example will be we're gonna write this double integral in terms of integral of f(x,y) dx dy instead. And the thing that we are looking for turn out to be the lower limit and the upper limit here. So we need the green one and the pink one that we're gonna put here. I mentioned before that you not be able to just interchange the order by just changing the order of integration in that way, because this one is too curved, this one is too constant, they are not the same. So the thing that we must do turn out to be we need to sketch the region. So the first one will be sketching the region. Okay, so for this one, the thing that I usually teach is gonna be, I'm gonna ask you what you see. The thing that you see is gonna be, you see that you have the variable y here, and you are having y lie between 0 and 2x. And you have x will cover from 0 to 1. Okay, so this one, and you have x between 0 and 1. So this is what you see, okay? So this is what you see, and you're gonna sketch the region by the thing that you're gonna see. So we're gonna sketch y equal to 0 and y equal to 2x, okay? So you're gonna sketch y equal to 0 and y equal to 2x. So this is what you have. So you have y equal to 0 and y equal to 2x. Let me change the color of this thing a little bit. So you have y equal to 0, which is the x-axis. And you have y-axis here. And you have y equal to 2x. So y equal to 2x is this line. Okay, so y equal to 2x. So you have y equal to 2x, and you have y equal to 0, which turn out to be this line. Okay, so it's gonna be the x-axis. So it's gonna be y equal to 0. And you have x will cover from 0 to 1. So the thing that I will plot will be, you have 0, x equal to 1 is here. Okay, so you see that this guy, it's gonna be the area between these two curves. Okay, so it's gonna be the region that bounded by these two curves, and you have only for x between 0 to 1. So it's not gonna be the whole region like this. It's gonna be region from x equal to 0 to x equal to 1. So it's going to be just this triangle. Okay, so for the region that we are looking for turn out to be just this. So it's going to be just this region S. Okay, so this one is going to be our region S. And you have the region S given by this triangle, and it's going to be from 0. Okay, so it's going to be from this, I'm not going to say 0, so it's going to be this one. So you see that this is the region S that we are having. Okay, so this guy will turn out to be just integrate over S, and we like to have x run first. So we like to have x run first. When x running, so it's gonna running horizontally. So it's gonna run in this form. So this guy, you have x equal to 1. And this guy from this green guy, so it's gonna be x equal to y over 2. Okay, so let me move everything to the other side so it's not gonna confuse you. Okay, so let me resize this guy a little bit. Okay, so you see, look at the green one. So the green guy has equation x equal to y over 2, and the pink one has equation x equal to 1. And you see x lie between two curves. Okay, so x equal to y over 2, so you must put y over 2 down here. Okay, so you have y over 2 down here, and let's use the green color. So it's going to be y over 2, x equal to y over 2, and you have x equal to 1. Okay, so you just have x equal to 1 to x equal to y over 2. And you have the pink one. The pink one turned out to be from x equal to 0. Okay, so for this one, you need to know where your y, okay, so you need to know where your y. So for your y, it's going to be, you see x equal to 0 and x equal to 1. So you must know the coordinate at this point. So it's going to be 1, and you have y equal to 2x, so it's going to be 2. Okay, so y equal to 2x. So this one gonna correspond to 2 on the y-axis. So it's gonna be, you see, it's gonna run from 0 to 2. So it's gonna be 0 to 2 here. Okay, so it's gonna be x equal to y over 2 to x equal to 1. Okay, so this one will be just example 11 that you have the reverse order for this guy. The next one, okay, so the next one kind of the same thing. So you have the double integral from 0 to 2 integral from 0 to y square fxy dx dy. The point that we are doing here is gonna be, you need to reverse this order to the double integral of fxy, and you need dy dx. And the thing that you are looking for turn out to be the curve, two curve, and you're gonna have two constant. Okay, so you need to reverse the order. The thing that you must see will be, you see this is dx dy, and this is dy dx. And this guy, okay, so you're gonna see, okay, so you see, so you see x between 0 to y square, and you see y between 0 to 2. Okay, so you see y between 0 to 2. So you're gonna sketch x equal to 0, and you're gonna sketch x equal to y square okay? And so you would have, okay, so you would have sketch x equal to 0 and x equal to y squared. So it's gonna be this guy and this guy. So you're gonna have x equal to 0, which is just the y-axis. So it's gonna be this one. Okay, so it's gonna be x equal to 0. And you have x equal to y squared, which turned out to be just y equal to root x. Okay, so y equal to root x turned out to be the parabola open to the right. So it's going to be like this. So this one is y equal to square root x. Okay, and you have x equal to 0 and x equal to y squared, and you have x between, not x between, y between 0 to 2. So you take a look here first. You see that you have curve x equal to 0. You have curve y equal to root x, which is this parabola, and the region turned out to be this region. Okay, so it's going to be continue infinitely many. However, the thing that you have, the range for y turned out to be from 0 to 2. So it's not going to be the whole picture. So it's going to be just only 0 to 2. Okay, so we're gonna just have this guy. Okay, so we're gonna just have like this. Okay, and it's gonna be 2 here, and it's gonna be 0 here. So the region that we have for S turned out to be this region. Okay, so it's going to be this region, and this one turned out to be your S. Okay, so this one is turned out to be your S. And when you have this region, you're gonna write y inside. So you see that y gonna, okay, so this one is y equal to root x, y equal to root x. So you have y equal to root x is gonna run, okay, so it's gonna run in this form, okay, so it's gonna run like this. So it's gonna be y equal to root x, and it's gonna be y equal to 2 up here, which is just a constant line. So from up here, the orange one has equation y equal to 2. Similarly, you need the vertex here. So you need this vertex. When y equal to 2, okay, so y equal to 2, you have to put into this equation. Y equal to 2, you must have x equal to 4. Okay, so it's going to be 4, 2. And this one will be projected on the x-axis. Okay, so this one is on the x-axis and on the y-axis. So it's going to be 0 to 4 and 0 to 2. And you see here that it's going to be running. Okay, so the way that this guy gonna run is gonna be, it's gonna run vertically. So this guy gonna run vertically. So it's gonna run from the green one, which is y equal to square root x, to the orange one, which is y equal to 2, turn out to be y equal to 2. And you have, okay, you have the next one turn out to be, okay, then the next one turn out to be 0 to 4. Okay, so it's going to be 0 to 4. Yeah. So I'm gonna just put 0 to 4 for my x's. So you see that my x gonna cover from 0 to 4 in this form, and my y turn out to be the green one to the orange one, and the curve is inside. Okay, so the curves are inside like I told you before. So in this case, it's gonna be just this one. Okay, so this is what you have for changing the order. Why did we need to change the order? The way that we need to change the order come from we need to do something like in example 12. that we like to evaluate the following iterated integral. So we have integral from x to pi of sine y over y dy dx, okay, and we have integral from 0 to pi of dx, okay. So you gonna see that this one is impossible to integrate, okay. So this guy, if you have the blue one, so this inside guy is impossible to integrate. Okay, so this one is impossible to integrate. So you're gonna have to, we must reverse order or change the order. We must change the order. So what does it mean? It means that you're gonna do the integral and you have sine y over y, and the thing that you're gonna change is gonna be, you're gonna change this guy to dx dy. And you see that after you change to dx dy, this one is working fine. Okay, so this one is working fine because if you like to integrate the inside, okay, so if you like to integrate the inside, this guy turned out to be just sine y over y integrate dx. Okay, so this one will become constant. Okay, so this term will become constant. So it's going to be constant. And it can be done quite easy. Okay, so this one. So the thing that we will need will be the yellow one. Okay, so it's gonna be the yellow one that you're gonna have for two curve, and you're gonna need the blue one. Okay, so you're gonna need the blue one for constant. Okay, so for this one, let me move everything a little bit lower. So for this one, this is the thing that we must do. Okay, so this one will be the thing that we're looking for, the yellow one and the blue one. Okay, how would we do that? So we're gonna sketch the region. So what do we see? So the thing that we are seeing, okay, so the thing that we are seeing will be, we see y between x and pi, okay, and you have x between 0, so you see y and you see x outside. So you see this one and you see this one. So for this one, you see x and you see what is called, it's gonna be x between 0 to pi. It's gonna be this one. So you're gonna sketch, okay, so you're gonna sketch y equal to x and y equal to pi. They come from, you have the middle guy, okay, y equal to x, y equal to pi. They are boundary, so they are lower and upper. So in this case, you're gonna sketch the lower one, which is y equal to x, and the upper one, which is y equal to pi. So from here, you're gonna just draw the line. Okay, so you just draw the line. So you have y equal to x. Okay, so you have y equal to x, which is just the straight line. Okay, which is just the straight line, y equal to x. And you have y equal to pi. Okay, so you have y equal to pi, which is this line. So you have y equal to pi. So you get pi, you get 0, okay? So in this case, this one is y, this one is x, okay? And you have the region from y equal to x to y equal to pi, okay? And you see that this one has the intersection. The intersection turned out to be pi pi because this intersection point is on the line y equal to x. So you see this one will be region S, and this triangle will give you everything you're looking for, okay? And you can project x equal to pi down here on the x-axis. And this one turned out to be just kind of nice, right? So it's gonna be just this integral, and we're gonna just have the yellow one. So the yellow one turned out to come from y equal to x, okay, and y equal to pi. So we have y equal to x and y equal to pi. So you need to run, okay, so you need to run dx. Okay, so you need to run dx. So it's going to be running from the y-axis to the blue line. Okay, so you have this guy to this guy, this guy to this guy. So it's going to be from the y-axis to y equal to x. The y-axis has equation x equal to 0. Has equation x equal to 0. So you would get in this direction, So it's gonna be from x equal to 0, okay, to x equal to y, okay, to x equal to y. Okay, so x equal to 0 to x equal to y, and the blue guy will cover y. The blue guy will cover from y equal to 0 to y equal to pi. So it's going to be 0 to pi. Okay, so it's going to be cover the 0, 1. And you see that this guy will be the thing that you're going to integrate over x equal to 0, x equal to y. Okay, and I'm gonna continue computing this guy. So it would give me psi y over y, and integrate dx gonna be x from x equal to 0 to x equal to y. So you would just have psi y over y, y minus 0, okay? And y minus 0 and y will get rid of each other. So you copy down, okay? So you copy down the outside integral. So it's gonna be integral from 0 to pi dy. Okay, so you have this outside integral, integral from 0 to pi dy, dy. So dy, so dy gonna also come down, okay? And this one will have equal sign, okay? The previous example, I didn't integrate, so you're not gonna see this calculation. I'm gonna just have one line answer. This one will be your final answer, and this one will be your final answer. However, for this one, we integrate this one because the question asks you to evaluate for value. So this is the thing that we are doing right now. So you integrate psi y dy. So for this guy, it's going to be integrate psi equal to negative cos y from 0 to pi. Okay, so it's going to be from 0 to pi. So it's going to be negative cos pi minus negative cos 0. So you would get negative of negative 1 plus cos 0 is equal to 1. So this number equal to 2. Okay, so that will be example 12. Okay, so it's going to be this integral. Okay, the last one for this clip is gonna be example 2. Okay, so we have integral from y to 1, from 0 to 1 of 1 over 1 plus x to the fourth dx. This again, okay, so this again, you see that if you would want to integrate the yellow guy, okay, so if you would want to integrate 1 over 1 plus x to the fourth dx, so this one again impossible to integrate. Okay, so because you not be able to use the technique that we have learned last semester for integrating this guy, okay, by part not working, partial fraction, impossible. For this one, it's going to be just, you need to, like what? You need to reverse the order. So we're going to reverse the order for this one to be double integral of 1 over 1 plus x to the fourth dy dx, okay? And after you reverse the order, you see that this one turned out to be constant, okay? So this guy turned out to be constant, and it's turned out to just, okay? It's turned out to just, you have this one, and you're gonna be able to integrate this guy, okay? So it's gonna be 1 over 1 plus x to the fourth times y, okay? So that is gonna be, you'll be able to integrate, okay? So it's gonna be this guy, and you have dy, okay, like before. So the thing that we will need the pink one, okay, so we will need the pink one up here, and we will need the blue one up here for the upper and the lower limit that we reversing. So the same thing, okay, so you gonna write down what you see, okay, so this one you have x and you have y. So the thing that you're seeing will be, you have y between, with y less than x, x less than 1, and you have y between 0 and 1, okay, so you have y between 0 and 1 and x between y and 1. So you're gonna sketch x equal to y and x equal to 1. Okay, so you're gonna sketch x equal to y and x equal to 1. And this guy will be, yay. Okay, so for this one will be my y and my x. Okay, so you have x equal to y, which is just this graph. Okay, so this one is going to be x equal to y. So this one is x equal to y. And you also have x equal to 1, which is this vertical line. So this is 1, and you have x equal to 1. Okay, and you see that it's gonna be the region bounded by these two curves. Okay, so it's not the whole thing. You have to see the range of y. Y turn out to be from 1 and up to 0. So it's gonna be y1 is here, y0 is here. So it's mean that you're gonna cover only this region. Okay, so you're not gonna cover everything. So it's gonna be just this triangle. So I'm gonna just write down 1 here, 0 here. Okay, so it's gonna be 1 here, 0 here, and the region is turned out to be this triangle. Okay, so it's gonna be this triangle, and you're gonna have is come from this green one to the red one. But we will need to reverse the order. So you must have y run first. So y in this case will run vertically. So it's gonna run in this direction. Okay, so it's gonna run in this direction. So it's gonna be coming from this line to the green one. Okay, so this line has equation y equal to 0, and this guy has equation y equal to x. Okay, so you get y equal to 0, y equal to 0 to y equal to x. So it's gonna be y equal to 0 to y equal to x. Okay, so y equal to 0 to y equal to x. And you're gonna have x, okay, gonna cover from constant 0 to 1. Okay, so x gonna cover from 0 to 1. X gonna cover from 0 to 1. So you have 0, sorry, y equal to 0 to y equal to x. So that's gonna be the pink guy. So you're gonna integrate this 1 plus x to the 4th. Okay, so you're gonna be 1 plus x to the 4th, and you have integrate dy, so it's gonna be y, it's gonna be y equal to 0 to y equal to x. Okay, so it's gonna be x over 1 plus x to the 4th, and you have integrate from 0 to 1 dx. Okay, so it's going to be integrate from 0 to 1 dx, this guy coming down. Okay, and dx gonna just come down here. Okay, so the last thing that we're gonna compute will be we're gonna need to integrate this one. So the way that we're gonna integrate this one is gonna be, you may have to think this one a little bit. X to the 4th, okay? So for x to the 4th here, it can be written, okay? X to the 4th here, it can be written as x square. Okay, so that is the thing that we used to do in Cap 1, okay? And this guy turned out to be double integral 0 to 1 x dx over 1 plus x square, okay? X square, okay? So that is gonna be u, okay? So you're gonna let u to be x square, okay? So you would let u to be x square. And you have du turn out to be 2x dx. So you have du over 2 equal to x dx. So this one is the yellow one. This one is the yellow one. Okay, and you have u equal to x square, u equal to x square. And you're gonna have x equal to 0, you get u equal to 0, and you have x equal to 1, you get u equal to 1, okay? And this guy will be integrate from 0 to 1, and you have 1 over 1 plus u squared du over 2. Okay, so this guy will be 1/2 arctan u from 0 to 1. So it's gonna become 1/2 arctan 1 minus 1/2 arctan 0. And arctan 1 is pi over 4, arctan 0 turn out to be equal to 0, so it disappear. So at the end, you're gonna just have this final answer. The final answer must be pi 8. Okay, so for this one, the thing that we have learned in this clip is gonna be about we have the double integral that not be able to compute the integration if you have the one order dx dy or dy dx. You must do the thing that we change the order, and after you change the order, you be able to integrate it. Okay, in the next clip, I will do more example to gain more understanding. So example 13, 14, and 15 will be in the next video, and you're gonna see that the thing that I did turn out to be a little bit different from the thing that we have done so far. Okay, so that wait and see. Okay, so I would think that all for this clip, and we gonna continue in the next clip for this next 3 example. Okay, so that's all.